Okay, what we're going to do now is try to figure out the way to calculate number of moles of a compound and number of moles of each type of atom in a certain amount of glycine. And so to do this, I first need to use the periodic table to figure out what the relative atomic masses are for each of these substances. So let me do that. Okay, so here's the periodic table. Carbon, it's a little hard to see, but carbon has an atomic mass of about 12. Hydrogen right here has an atomic mass of about 1. I'm just rounding off to the nearest integer. Nitrogen is about 14, and oxygen is about 16. So now, if I go back to the question, first thing I have to do is figure out what the molar mass of glycine is. So the molar mass of glycine is going to be twice the mass of carbon, which is about 12 AMUs, plus 5 times 1 for the hydrogens, plus another 14 for the nitrogen, plus 2 times 16 for the oxygen, which, if I work this out, gives me about 75 grams per mole. So now that I know the molecular weight, I can figure out the number of moles. And the way that I do that is I find the number of moles by taking the mass and dividing by the molar mass, or molecular weight. So I know that the mass is 3.06 times 10 to negative 3 grams, because that was stated in the question. I can divide this by the molar mass, which is 75 grams per mole. So if I work this out, I get about 4.08 times 10 to the negative 5 moles of glycine, C2H5NO2. So now the question also asked, how many moles of each type of atom do I have? So now I just have to look at each number individually. Okay, and so for carbon, I have twice as many. So 2 times 4.08 times 10 to the negative 5 is 9.16 times 10 to the negative 5 moles of C. For hydrogen, it's going to be 5 times as much because it's C2H5. Okay, so 5 times that is going to be 20.40 times 10 to the negative 5 moles, which I could also write as 2.04 times 10 to the negative 4 moles. And for nitrogen, I just have one N in there, so that's actually going to be the same number, 4.08 times 10 to the negative 5. And for oxygen, once again I have a 2-to-1 ratio, so I multiply this by 2, and I get 9.16 times 10 to the negative 5 moles of oxygen.